Hello everybody. Last class we have seen what is MRP1. The three inputs to MRP1 are MPS, bill of material and inventory status file. And the output which comes out of MRP1 is the planned order release. So in today's class we will see a practical example on how to compute MRP1 for the components. And then we will finally discuss the brief concept on MRP2 and ERP. So we have taken a problem to understand how these MRP computations are done. So the problem is a company manufactures a product X to supply 80 units in week 2, 120 in week 4, 120 units in week 6 and 100 units in week 8. So the finished product for the company is the product X, and the company is supposed to supply 80 units in week 2, 120 in week 4 and then again 120 in week 6 and 100 units in week 8. It's given that X is made up of 2 units of component A, 1 unit of component B and 1 unit of component C. Now here is a table which shows that what is the ordered quantity. We have already learned the concept of EOQ, economic order quantity. So for A, the order quantity is 600. That means whenever we place an order on the supplier, the order quantity is for 600 units. Similarly, the order quantity for B and C are given. Now this is lead time, the lead time of procurement. For A, it is 2 weeks. So 2 weeks is the lead time of procurement for A, 3 weeks for B and 1 week for C. And the inventory, what is given in inventory status file, those figures are shown here. Presently we are having an inventory of 200 units of A, 440 units of B and 100 units of C. This is given in the problem. Now apart from above requirements, that is all these requirements, 180 units of B are required in week 6. This is the additional requirement for component B and which will be required in week 6. This we have to take into consideration. Again, 600 units of A are scheduled to be received in week 2. That means we have already ordered for 600 units of A and which are in transit and which we are going to receive in the second week. Lead time to manufacture X from 3 components, that is A, B and C, is 1 week. It's given in the problem. So now we have to compute the MRP plan for the components A, B, C. I hope the problem is clear. So we are given with the end product X, the scheduled quantities and the need dates for the component finished product X is given. From here, I'm sure you can understand that from this information, we should be able to design the MPS for the product X, which is the end item. Now, here we are given that. So let's see how the MPS for X is to be designed first. So this is the MPS for product X. Okay. So we have written MPS, master production schedule for X. Now it is given week wise, so we have been given information for till 8 weeks. So here we have written weeks and the information is for 8 weeks, so we have designed the MPS for 8 weeks. Now as per the information given in the problem, the requirement, the total requirement or the gross requirement is 80 units and that is required in second week. Whatever information is given in the problem, we have put it here. So 120 units of X is required or to be delivered in 4th week, 120 in 6th week and 100 units in 8th week. So this is my master production schedule for the final component or the finished component or the specific end item, that is X. Okay, so this is one of the inputs to MRP. The other 2 inputs are bill of material and inventory status file. Now let's make the bill of material based on the information given in the problem. Here is the bill of material for product X, as you can see here. Now X is the finished product. It is composed of 2 units of A, 1 unit of B and 1 unit of C. It's given in the problem, right? Now As I have told you that the figure in the parenthesis tells us how many units of that particular component go into making 1 unit of the finished products. So 2 units of A, 1 unit of B and 1 unit of C are required to produce 1 unit of X. The figures 1 week, 2 week, these are nothing but the lead time. Right? So 1 week here shows that the lead time to manufacture X, we are manufacturing X from its components A, B, C, and the lead time to manufacture X from its components A, B, C is 1 week. Similarly, as you can see below A, we have written 2 weeks. That means the 2 week is the lead time of procurement because A is not being manufactured in-house. It is procured from outside. So 2 week is the lead time of procurement for A. 3 week is the lead time of procurement for B and 1 week is the lead time for procurement of C, which are given in the problem. Okay, so my master production schedule is ready, my bill of material is ready, and the third input, which is inventory status file, that is also given in the problem. The present inventory for A is 200, B is 440, C is 100, and that information forms my inventory status file. So 3 inputs are ready. Now we have to compute the MRP plan for each of the 3 components. Okay, now let's see what we do, how to do this. Now the structure, okay, I will just cover this. You have to remember one thing, if we just focus on this, the format for the MRP plan always look like this. The format of the MRP plan for any component looks like this. Now what we have written here, order quantity. Suppose I am manufacturing, so how many components we are having in this particular case? We have got 3 components A, B, C. So since there are 3 components, we will have 3 MRP plans. Now this I have tried to make the MRP plan for the component A, right? So just see what is the format. The first cell we have to write the order quantity. Order quantity for A is how much? Since we are making the MRP plan for component A, so we have written the order quantity for A is 600 is given. Lead time of procurement for A is 2 weeks. That is also given in the problem. SS, that stands for safety stock. Are we maintaining any safety stock? In this case, we are not maintaining any safety stock. So safety stock is 0. Okay. Now, the MRP plan is to be made for 8 weeks because we are given data for 8 weeks. What are the other things we need to know? Second row is gross requirement. That means total requirement. Scheduled receipt. How many units we are going to, how many units are scheduled to be received. Inventory in hand, plan, order, release. So this is the format. You should always remember this format. So first cell consists of order quantity and the lead time for the component for which we are planning to compute the MRP plan. Second row is the gross requirement. Third is scheduled receipt. Fourth is inventory in hand. In this particular case for A, if you look back at the inventory status file, it shows that A has an inventory of 200 units. So that 200 units, we have kept it here. Inventory in hand is 200. And last row represents your plan, order, release. Now, come back to the MPS. We have to manufacture or 80 units of the finished product X should be ready in the second week. Now X is composed of A, B, C, and what is the lead time of manufacturing X from its components? 1 week. So if you need 80 units of X in the second week, when the components should be available to you? The components should be available to me 1 week before, because 1 week is the lead time of manufacturing X from the 3 components. So if I need X in the 7th week, A, B, C should be available to me in 6th week or on 6th week, so that I need 1 week time to assemble A, B, C to make the finished products, and my finished product X become ready in the 7th week. Okay, so based on this, we have to find out the gross requirement for the components. Now, 80 units of X are to be delivered in the 2nd week. For these 80 units, how many units of A are required? Yes, you are correct. For 1 unit, I need 2 units of A. So for 80 units of X, I need 160 units of A. And when I will be needing? Just 1 week before. So for making 80 units of X, I will be needing 160 units of A, and that I will be needing 1 week before, because 1 week is the lead time of manufacturing X from the 3 components. I hope this is clear. So that's what we have done, and we have written this. Just see, the gross requirement is 160 to make 80 units of X, and that is required in the 1st week. To get the delivery of 20 units of X in the 4th week, I need 240 units in the 3rd week. Similarly, to deliver 120 units in week 6 for the finished product X, I need 240 units in week 5 for the component A, and 200 units to manufacture 100 units, and to supply in the 8th week, I will be needing 200 units of A 1 week before, that is in the 7th week. That is how we make the gross requirement. I hope this part is clear. Now, it's given in the problem that 600 units of A are scheduled to be received in week 2. So just in the schedule receipt row we have put 600 units in 2nd week. Okay, up to this it's clear. So we have put all these figures based on the problem. Now inventory in hand, we'll come back to this 600 later on. Now inventory in hand is 200 per unit for the component A. So in the 1st week my requirement was 160. Inventory in hand before the 1st week was 200. So at the end of the 1st week, I am having an inventory of 40 units. I hope this is clear. I repeat, 200 inventory I was holding. 160 was the requirement in the 1st week. So at the end of 1st week, I am holding an inventory of 40 units. In the 2nd week, I have 600 units of A are scheduled to be received. So my total stock becomes 600 plus 40, that is 640. And though there is no requirement in 2nd week. So 640, I'm holding a stock of 640 in the 2nd week. 3rd week, my requirement is 240. So 640 minus 240, 400 inventory I am holding. And that is continuing in the 4th week, because there is no requirement in the 4th week. In the 5th week, my requirement is 240. So 400 minus 240 gives you 160. That inventory continues in the 6th week also, because there is no requirement in the 6th week. 7th week, just see, 160 is the inventory I am holding at the end of 6th week, and 200 is my requirement. So will I be able to meet my requirement? No. That means I have to receive something in the 7th week. Otherwise, I will not be able to meet my requirement of 200 units in the 7th week, because I am holding a stock of 160 units only at the end of 6th week. So I have to receive something. And since my order quantity is 600, I will be receiving in a batch size of 600 units. So that is the reason I have written here 600. So 600 I am scheduled to receive in the 7th week. 160 I was holding the stock at the end of 6th week. So 160 plus 600, that is 760, minus 200 was the demand. So 560 I am holding stock at the end of 7th week. There is no requirement in the 8th week. So I am continuing with the stock of 560 in the 8th week. Now just see, since 600 units I should schedule to receive in the 7th week, otherwise I will not be able to meet my requirement of 200 units. This 600 units are to be, an order should be placed for this 600 units. But the question comes, when should we place the order? The answer is also with us because the lead time is given. Lead time for A is 2 weeks. It's given in the problem. So if you need 600 units in the 7th week, when you should place the order? 2 weeks before. That is 1 and then 2. That is in the 5th week, I should plan to release the order, and that's what you've written here. And that is why you have written here 600 units. So 600 units of component A, the planned order should be released for 600 units for component A in the 5th week so that we can receive the same amount in the 7th week and there is no stoppage of my production. So what is the output of this MRP for component A? Output is 600 units of A are to be ordered in week 5. So this is the MRP plan for component B. As per the information given in the problem, order quantity is 400. Lead time of procurement for B is 3 weeks. Now since I need 1 unit of B to manufacture 1 unit of X as given in the bill of material, so to manufacture 80 units of X, definitely I will be needing 80 units of B. But I will be needing those 80 units 1 week before I need X, because 1 week is the lead time of manufacturing X from its components A, B, C. So that's what we have done here. 80 units of B will be required 1 week before. So 80 units will be required in week 1, 120 in week 3, 120 in week 5 and 100 units in week 6. Now this is clear. Now apart from this, it is given in the problem that 180 of units of B are required in week 6, and this information also we have given. This information also we have put in the gross requirement row in week 6. Okay. Now there is no schedule receipt for component B. It is not specified in the problem. Inventory in hand is 440. So to start with, I just write this. 440 is the inventory in hand. In the first week I need 80 units, so my inventory in hand at the end of first week is 360. There is no requirement in second week, so this 360 will continue. So I will write here 360. I can't write properly. Now 360 minus 120, so it becomes 240. There was no requirement in week 4, so again 240 remains. 5th week the requirement is 120, so my inventory comes down to 120. 6th week my inventory, my stock is 180. My stock is 180 and my inventory at the end of 5th week is 120. I will not be able to meet my demand in the 6th week. So what I do, I have to receive something in the 6th week. In what quantity I can receive? Since the order quantity is 400, I have to receive in an order quantity of 400 in the 6th week. So my total inventory becomes 400 plus 120, that is 520, out of which my demand is 180. So I am left out with 340. 340, I hope you understand. 120 was my inventory in the 5th week, at the end of 5th week. In the 6th week, my demand was 180. So it cannot be furnished by this quantity. So I have to receive something. I should schedule some receipt in the 6th week, and that too, it should be in terms of my order quantity, which is 400. So my total quantity of stock becomes 400 plus 120, that is 520, out of which 180 is the demand. So my total inventory at the end of 6th week is 340. The demand in 7th week is 100. So my stock level comes down to 240. There is no requirement in the 8th week. So my stock level continues to be 240 at the end of 8th week. but I have received 400 units in 6th week. So if I have received 400 units in week 6, that means I should place the order for 400 units of B when 3 weeks before, because lead time of procurement for B is 3 weeks. That makes me to place an order for B 3 months before, 3 weeks before, that is 1, 2, 3. So it comes here, it will be 400. Right? So as per this, we can say that the MRP output for the component B is to release an order for 400 units of B in 3rd week. Okay, that should be the output that you should specify over here. So 400 units of B are to be ordered in week 3, right? So this is how the MRP plan for the component B has been developed. I keep your home assignment. You have to determine the MRP plan for the component C. Hope you will be able to do that. Okay, if you have any problem, then you can always put your comments, put your feedback in the comment section. Thus, we have seen how these MRP computations are done. Now, if a company deals with few number of items, the MRP calculations or computations can be done manually. But generally, the company deals with thousand and thousand of items, and in that case, the MRP computations for each of the components, it is not possible to do manually, and then we have to take the help of computers. We feed the data or the inputs for MRP, that is MPS, bill of material and inventory status file. All these inputs are fed into the computer, and the MRP package or the software does the computation and gives us the output, that is the plan order release. Now, if the item is manufactured in-house, then the plan order release will be in terms of plan order for production. Or if the item is to be procured from outside or from a vendor, in that case the plan order release will be with respect to plan order of procurement. Now, while the MRP that has grown out of traditional production and inventory management does an excellent job of planning for materials, but such a technique is not fully effective in achieving the business objectives unless and until we consider all the resources of the organization, of the manufacturing organization. I mean to say that no matter how effective is my business, my material plan is, if we do not take into consideration the financial resources, if it is not backed up by the financial resources, or if we don't have sufficient labor to carry out my production, or even if we have sufficient financial resources, sufficient laborers to carry out my productions, machines are also in the right condition, but finally whatever products we are producing, if it is not being sold in the market, if there is no assurance from the marketing or the sales department, then what is the use of going for such detailed materials planning? So MRP, it basically focuses on planning for materials, but that is not good enough. We have to take into consideration other resources of the organization, and that is done in MRP2, which stands for Manufacturing Resource Planning, which integrates all the resources of the manufacturing organization to ensure that the material planning can be implemented to achieve the business objectives. So MRP planning, MRP1 focuses only on the material planning part, whereas MRP2, which is manufacturing resource planning, which takes into consideration, which integrates all the resources of the manufacturing organization, of the manufacturing organization, to see that the material planning can be implemented to achieve the business objectives. It has simulated capability or simulation capability to answer what if. That means if enough financial resources are not available, in that case, what should be the material plan? MRP2 will talk about that. Or if we don't have enough laborers to carry out my production, in that case, what should be the material planning? That is also guided by manufacturing resource planning. Now, although MRP2 has overcome many of the defects or drawbacks of MRP1, in today's uh, changed business scenario, it is not that much relevant because of the following two reasons. Number one, Number one is that manufacturing has shifted from make to stock to make to order, as because customization has replaced standardization. Earlier companies used to produce in bulk and they used to stock or store their goods with the assumption that all the goods for their manufacturing will be sold in the market. But since customers' tastes have changed and because of innovation, new products are coming to the customers, they have got a wide variety of choice. So we cannot expect that the customer will be buying the standardized product. Rather, customers are looking for customized product. Secondly, quality and price are the minimum requirements for an organization to exist in the market. Competition moved on the basis of aggressive delivery, flexibility, better integration with the supplier and the customers, and to provide a wide range of variety to the products to the customers in terms of product differentiation. So MRP2 was replaced by ERP, which stands for Enterprise Resource Planning. While MRP2 focuses on the planning and schedule of resources of the manufacturing organization, ERP, that is Enterprise Resource Planning, it also schedules and plans the resources of the supplier in order to meet the dynamic customer order and schedules. Thus, we have seen that in MRP1, the focus is on the material planning aspect only. In MRP2, all the other resources of the manufacturing organization are taken into consideration so as to make the material planning more effective. And in ERP, which stands for Enterprise Resource Planning, not only the resources of the manufacturing organization but also the resources of the supplier are taken into consideration so that the dynamic customer orders and schedules can be met. This is for today's class. Hope you have understood. I would request all of you to stay back home and stay safe. Thank you.